this one's a straightforward algebra. Okay, so a box contains R red balls, and this is problem 27 from 2013 State Sprint. A box contains R red balls and G green balls. When R more red balls are added to the box, the probability of drawing a red ball at random from the box increases by 25%. What was the probability of randomly drawing a red ball from the box originally? Express your answer as a common fraction. And so we can write that, okay, so originally, the original probability was the number of red balls over the total number of balls. And then after we add R more red balls, then the probability becomes R over 2R plus G. But we're also given that the probability increases by 25%. So then that means that our new probability, 2R over 2R plus G, equals 1.25 times the old probability, or 5/4. And then we can just turn that 1.25 into 5/4. So this becomes 5R over 4 times R plus G. And then we cross multiply, and so we have that 2R times 4 times R plus G equals 5R times 2R plus G. And you expand out, you get 8R squared plus 8RG equals 10R squared plus 5RG. 3RG equals 2R squared. 3G equals 2R. And a nice trick for proportions is that when you get to a step like this, there's no reason not to just like randomly for no reason set R equals 3 and G equals 2. It's not, this isn't necessarily true, but it maintains the proportions, and that's all we really care about. And also technically, since R equals 3, there are no units there, so it's technically works. There's 3, not balls, just 3 units of balls. Okay, and so we have 3R, R equals 3, and G equals 2. And so now we just have to, I would go back and, because it takes very little effort, I would go back and check. So when R equals 3 and G equals 2, this becomes 3/5. And 2R over 2R plus G equals 6 over 8, which equals 3/4. And there is, in fact, a 25% increase here. And then so it's asking for the original probability, which is 3/5. We